All right. Good afternoon. Had a good lunch?
Yeah.
Good. So my name is Benoit Marchant. I'm the CEO of Montage Studio. And we're going to talk about what we do today in terms of web development and what we should be looking at doing in the future. But before we talk about the future and the present, how about we go back memory lane? So I had this exact same slide, I think, last year, slightly different. So do you guys know what that is? Any guess? No? It's too old.
It's next application.
That's right. But it's not any Next application. It's World Wide Web.app, which was the first application that Tim Berners-Lee wrote at CERN on the Next cube, where he was able to crystallize the idea of what the web could be or was going to be. And Tim says something that I could do in a couple of months, what it would take me over like a year on others. And if I count correctly, that's about six times faster. Right? So what's important here is that it turned out that Tim had access to that specific machine, which was the first complete OS to provide a complete object-oriented approach to not only development, but also authoring with Interface Builder. And that made him capable of expressing his ideas a lot faster. He would have been able to do the same thing on Windows or on Unix, most likely. It would just have took him like 6 times longer. He may have given up. He may have got distracted or sidetracked. So anyway, so that's what the power of platform is. It lets you do something faster that you could probably do otherwise, but doing it faster. So if you look at what platform we've been living with, the first really two big one that we know in the PC era were the Mac one, which today is inherited from Next. So you have in all these platforms that we're going to go through, you're going to see two patterns. There's a layer of frameworks, and then there's a layer on top, which is more in terms of authoring, what we call IDE or these kind of things. There are visual tools. There are software for us, for developers, so we can work faster. Microsoft is another big platform. Same thing. You got .NET, and you got Visual Studio. Another one that was very successful, is kind of like gone now for all practical purpose, is Adobe Flash. You had the Flash runtime, ActionScript 3 and all that stuff, and then you had the Flash Professional, which used to be called Flash Builder. And that layer, especially Flash, is, as far as I know, the only platform that was able, when it was actually in work, in action, to bring designers and developers together. You could have interactive designers working on the same medium that the application will be in. And that is unfortunately gone, and it's a big miss. We need to get that back. So why does it matter? These platforms let you create software, and on the web platform, we are focusing on the front end. Here, us in that room, I suppose. So I'm sure some of you do back end, but if we focus on what we do inside the browser, these are meant to be used by people, right? Not by services, by other cloud services, by people. So we knew for a long time, but it's been restated very clearly by Apple iPhone success, that the way you interact with an app is critical. If your app is not easy to use, intuitive, just by pure attention disorder, people will just move on and try another one. Right? So you got to pay attention to that. And to achieve that, you need two things. Like I said, you need designer and developer working very well with each other to make sure that you get the best option. But you also need to be performant. If your UI is slow, if it's not responsive, if it's well conceived but poorly executed, it's not going to work either. So let's focus on the developer-designer relationship. It turned out that I think the web platform is the best to solve that problem. Why? Because we naturally have CSS, and that's for more like presentation that's used by designer. we have JavaScript, which is a programming language that's used to code the logic of an application. And there's the magical HTML in the middle that actually bring them together. HTML combined with CSS is a presentation. HTML combined with JavaScript is for the development. But the problem is today, many solutions that exist are favoring one or favoring the other versus looking at the problem as a whole. Like, you don't make software with designers on one side and developer on the other side. If you do that, it doesn't work. It costs a lot of money for not much good results. So that's the very interesting part, getting them together. The other aspect is performance. So the web has not been growing to what it is today, which is probably the biggest software platform in the world, by its excellence in user experience, unfortunately. It has grown by its excellence in linking, right? You click on something, you load a page somewhere else, you're there. Instantly. You don't need to download anything. There's no friction. You just navigate around. You can do that forever, right? Until you die, really. And that's what has brought the web ecosystem to what it is. Now, there was an article recently on a blog post from someone from Andreessen Horowitz that was claiming, and unfortunately the numbers are true, which is the mobile web is declining. Like, more and more people spend more and more time on native apps versus mobile web. Whatever that mobile web is, whether it's it takes the form of what you think is an application or whether it's a site optimized for mobile, it doesn't matter. People are spending more time in apps. Why? Because it works better for them, I suppose, right? People don't care how you make your app. That's not their problem. They just want to use it to solve what the problem does, right? So how can we solve that? So if you look at client application, Android or iOS, or same thing would be for Cocoa or desktop, for that matter, you have the entire code of the application that runs on the client. All the assets start from there. And then eventually, if your application has a cloud component, then the code has all the logic, then turn back to the server, and then talk to that and get data back. What I want to focus on is the same thing, is rich client applications where your application, instead of being built with Java and XML files or Objective-C and serialized objects, is built with HTML, JavaScript, and CSS. Other than that, so these assets will be served as on-demand or wrapped into a native shell if you want to do an hybrid, that works fine. And then the whole logic is coded with these static assets, and then same thing, they turn back and they go to the backend to get data. After that point, you're back in the same kind of architecture of applications. The problem is that we don't have as much tools to help us do that on the web. So what can we do? Well, there have been a platform that's been around for a very long time, right? 35 years in the making, to go from Next Step through Web Objects, which was the first object-oriented application server in the world, to macOS 10 and now to iOS. 35 years of engineering on the same code base refined. Can you imagine that? 35 years. There's not a single stack out there that has lived so long. Not even on Microsoft side. They've done many iterations of Visual Basic. They ditched Windows, with the early Windows version several times. Now .NET has been stable for a while, but it's not 35 years. It's like 10, right? But the length doesn't matter. What matters is that through these 35 years, millions of desktop, web, and mobile applications were built by millions of developers, right? So, which tells me something. If these guys were able to ship that many iterations of applications, what they've been using, and that was one of them, this is what I know from the inside, was really helpful. Otherwise, that would have failed and they would have used something else, right? So the question is, why should we reinvent the wheel? We should just go and steal it. So how about we take all of that and take the concepts that are coming from there and look if they can be useful. So Web Objects had an extremely well-designed of components, which was very well abstracted, very well designed, proven many times. They have templates in these components. Cocoa has something like the draw loop, which is something very important to address to be able to paint only as needed, as frequently as you can, and that degrades gracefully when your CPU or GPU is not as quick as you would want, but you still repainting the last action from the user. That is a design that is critical. It's been, and guess what? It's been invented on Nextstep when it was on Motorola 6040, which were not speed demons, right? So they had that program before on desktop before we had it on mobile. So all of that on top of HTML5 is something that what we decided to do is take that and that we call that Montage.js, but that was the spirit behind. It's like steal the good ideas, make sure we translate them, we apply good editorial appreciation to make that non-Coco-like but more like web-like, but take the key pattern that we need to grow and do that. So that's one piece of the puzzle. That's just a layer. Now, once you do that, you still have to go and build the rest of a platform, which is growing up the stack and offering what I would call a universal SDK, because HTML5 is universal. It just runs everywhere. We don't have to do anything for it. And build another set of layers that helps you work, not just by hand coding everything. There's nothing wrong with hand coding, but there actually are faster way to work. I'm going to show you some. So trying to grow the platform from the bottom up to have something that is on par at some point in the future with what the native environment has to offer. So now I'm going to switch to showing you a demo of what that can be. So this is Montage Studio. So Montage Studio is that layer on top of Montage.js, trying to provide an opinionated environment that lets you do things in a way that are more efficient in certain ways. It's not about removing the coding necessary. It's just replacing some of the coding we do that's not very interesting or productive and just doing it slightly differently. So Montage Studio sits on top of GitHub. So I'm already authenticated there as myself. So what you see here are some of the projects that I have in my GitHub account. So we're going to take a look at one demo that we show at JSConf. And it's a demo that uses the REST API of WordPress, which will be standard in the core of WordPress later this year. And we just wanted to show what we could do with that. So here you see the anatomy of Montage Studio. So on the left side, you have all the assets of the project. So one thing you should realize here, if you're in that ecosystem, is the node modules. So Montage.js uses CommonJS. So we have here package.json. That's what you would expect, except that we built a UI for it. So this is the only UI in the world to manage CommonJS packages, actually. We did it for the front end. But you have here the basics, the name, the version, here the dependencies, and here this directly wired to NPM. So if you want to add something for Facebook, for example, you could search that and see what. So there's 20 packages. You could just do that and just add the dependency if you want to. I'm not going to do that, but you get the idea. So every Montage application starts by a main component, which, by the way, the index is as simple as you can get. You got all the CSS you want. This is all boilerplate for the icons, so you can host that on your home device, on your home screen if you want to. And the only object that we start with is the loader. You can customize your own loader. But this is a regular web page. So if you have a first level of animation you want to brand your page, this is just a web page. Just go and do that. So by convention, and again, you can override that, is the main component that we load is this. So you know what? Since the screen is actually small, I'm going to bring a little helper here. It's not huge, but that should do it. Okay, so one thing we offer is live preview. So this is the app itself that we coded. So we get all the. I'll show you how it works. We'll get all the assets from the WordPress, and we just render it with a nice carousel. Okay, so I'm going to use that URL and put it inside the iPad. So AARK rn dot project dot montage studio dot net. Okay, so when I do that, I'm being asked a code. So for security, you don't want anybody to snoop in. So I'm going to punch in the codes. It's AAK, AAKC, and KD CF, right? Okay. You can join too if you want, by the way. If you have a device and you want to follow that, be my guest. So that URL, and once you get there, does anyone want to try? It's up to you. I just need to know, so I switch to the other one or not. So here's the app. Here's the app running on the device. Okay. Right. So let's go back to look at what we have here. So every component in Montage lives in a folder which has a .real extension. So it's a convention. And if you open that folder, you're going to see it's all a mini site. So the templates of components in Montage are full HTML5 documents with doc type and all, which means you can give it to a web designer that has no idea about Montage, and this is going to write a page like he would write otherwise, with his own link CSS, which is that CSS here. That's the CSS of the main component. It's a CSS page. And it's linked through a link, as here, as you would expect. Right? So that's all created by default for you when you create a component. And the reason why it was designed that way was to facilitate how web designers and web developers work with each other. There's no templating language in Montage.js because we don't like that, and it's inefficient. You have to learn it, and then you got logic that bleed into your code. It's not standard. You can't view that by itself without having the templating logic running. Is there? No, we don't need that. So in Montage, the way the templating works is by associating a component, which is a Montage object, to a DOM element. Once you've made that association, that component is taking over that piece of the DOM as his own. And if he has his own template, he's going to bring that from his own template, bringing it in, and replace the tag you gave him, you assigned to him, with whatever he needs. If he needs something, you can just write code into the draw method and just insert stuff there with no template. You can do that too. So the whole point of Montage Studio is so you don't have to go down if you don't want to. So I'm going to close that and go back to here. So here you have a more high-level view of what's going on. So the owner, how many of you are familiar with Coco? Okay, so the same concept exists in Coco in a nib, where the owner is a placeholder for the object that's going to load that template. So it's going to be a component here. So the component is going to load that thing, and each component of that kind is going to load that thing, and each time a new instance is going to be the owner, the placeholder, right? So the placeholder is your component. And here underneath that, indented to show the relationship, you have all the objects that were created for that, to implement that main component. So you have a WordPress connector, which is a JavaScript object. It's more like a model layer that's literally talking REST to JSON, to WordPress. That's what the guys do. The post controller is a range controller. So it's going to get an array of JSON objects, and it's going to manage that for you, dealing with the UI. So it's going to take selection. It's going to take, you can change the range you want to display, stuff like that. Again, similar to what you find in other places. The header is this, the top, with the WordPress logo, the title, and that's the bar on top. Then you got the post. So the post is what you get when you click on one. So that's the post. That's the post component right there. We're going to go in detail. And you get the flow. So the flow is a bit of a magical component. The flow is the one that does the kind of 3D carousel effect. And the flow is well, one thing we believe a lot in is composition. So the flow lets you from the outside tell what you want to flow, what kind of components. So here, we're flowing a card, right? You can flow your own thing if you want to. So the card is just that component here, which is basically showing, it's one of these, right? That's a card. That's a card component. And the card component has its own real, of course, where you have the text and you have the image, as you would expect. There's only image and text. That's all there is. And if you look at how they're done inside, if you want to go down to HTML, you got the CSS here, and the code is simple. You got the div. The data montage ID is how we hook up the serialization of objects to the DOM. And then the rest is just the card, the front of the card, the back of the card. I mean, it's well organized. And one of the benefits of structuring an app like that is you can have multiple people working on all these components at the same time. They should be designed so you can reuse them in other places. So they are all self-contained, right? They get data in through the owner. You pass data to that. And then the owner basically delegates, if he wants to, these data to subcomponents to do the rendering until you reach a point where you need a complex widget. And then you're going to use a component to implement a complex widget as well, like the flow, for example, is a component itself. So let's go back to the main. And I would like to show you a little bit more of what you can do with the flow. So the flow is a component that has, so by the way, here, let me finish the tour. Here you have the tree of the body, and it shows you, the blue shows you that components are assigned, which components are assigned to it. On the right side, you have the inspector. So these are dynamic properties that we have a system of metadata. So for example, I can go on the owner, I can add a property and say, I don't know, it's going to be foo. And foo would be, so here it just created me an inspector entry for foo on the fly. And if I tell it that foo is a Boolean, it's going to turn that into a checkbox. So the more effort you make to create semantic around your objects, the more we can help you to do stuff like autocomplete when you do data bindings and stuff. So for example, when you do look at, for example, the bindings that gets the contents inside the controller, that binding bind the content property of the arrange controller to the source of the data, which is the WordPress connector.posts. That's the array that you get. So if you provide metadata, we know as you type the path, we know we can help you navigate that more effectively. So on the right side here, you have basically the contents of the packages that you've decided to use in your package manager. So here we have the app. You always start the app, which means you see here all the one that you see here. So you can reinstantiate that component you created in other places in your app. Just once you create it, just become available immediately to be reused. Down there you see Montage, which is the base framework, and then there's Digit, which is a widget set designed for touch. And then there's another package which is to get the WordPress specific information. You also have assets here. There's none here. So let's go back to the flow. So the flow is a complex object where you can have elastic scrolling. So elastic scrolling, let me show you. So if I remove that and you just scroll, right, it's linear. If you add elastic scrolling, however, you're going to see the counts spreads together, and then they get closer together based on the speed of which you scroll. But let's go to the inspector of the flow. So the flow is a generic component where you can author the path of the objects that you want. It's like a list, except that the list is really a 3D Bezier curve. So instead of being linear, vertical, or horizontal, you can do pretty much as anything you want. So to show you what that means, I'm going to try to do something acrobatic, which is I can change the curve here, and you can see in real time on your device what does it mean. Okay? I can change that here, the other side, make them more stack, turn around. Right. And you can go on each knot, for example, and you can assign properties. So let's say on this one, on the end, we would like them to be, we want them to rotate as they go, for example. So you could do a rotate Y as they move toward the end, right? So now when you scroll, they rotate to the left. I can accentuate that. Whoops. Oh, sorry. And what's great is you can do that on an iPad. You can do that on another device, portrait. You can do that on another one on Android. And you can share that with your team or your customer, wherever they are, because this is all through the cloud. And that's not something that's specific to the flow. Like any component you add to your project, or you remove, or you tweak, you're going to benefit from the same thing. So you can, especially when you start being able to reuse components that way, you're likely some of them will be reused in several places in your app. They may have different sizes. They may be receiving different kind of data. So you can put 3 versions of your app in different states where you exemplify these different places where the component is used and get data, right, from your cloud. And then you can start making changes. You're going to see immediately, as you make changes, how it impacts the 3 places where that component is used. So instead of like doing iterative QA one after the other, you can see it right away as you do it. You have the right information to make editorial decisions like, oh no, okay, I just did that, but it screwed up the Android one. Okay, I need to do something else. You know immediately. So that's an example of what you can do with the flow. Let me, any question? No? It doesn't feel too magic? There's no magic. I mean, let's talk about how it happens. The reason why so network-wise is all WebSockets, right? There's no other way to do that on the web stack. But the reason why we're able to do that is because of the design choices that we've made, the way these reels are structured. We have a serialization of objects. We know where these objects, we know the entire tree of your app because you told us, right? It's like right in their face. It's not imperative code that we can't read. Like there's no divination going on, right? If that was written by pure codes, hand coding everything, you couldn't do anything with it because you don't have the information. Now we have a tree. We have a tree of a component, and in each component we have a tree. We know which objects are being instantiated, of what type they are, what property they have. So when you change the properties here, we know where to poke them in each of the clients that are connected to it and apply the very same changes to the distant sibling all in the same place in the app. Same for adding, right? When you're adding an object to the reel, we know which reel you're adding into. We are going to add an object of the same type in the clients on the fly. Same when you remove. So it's really reaping the benefits of, and we did that for a reason. So we could do stuff like that. But there's no magic. Once you understand how it works, it's like, duh, okay, yeah, sure. But it's still very, very practical. So let me, yes?
So how does it work with dynamic content? This looks like a static content. You have some
you mean
frame and data which you are playing around with. But
would,
the cards were getting added based on some
yeah. So that's based on the database content of the WordPress instance we're talking to. So in that case, there aren't many images because it's a demo one, right? So if you had a large collection of data, then it's all a matter of managing the cursor as you move the array. And so it's an excellent segue to highlight that the fact that the flow component has frustum culling. So that means like you could have 5,000 images, we would only display 1, 2, 3, 4, 5, 6, like let's say 10 of them, right? And not the rest. The flow knows, mathematically speaking, we analyze the Bézier curve, we know what's clipped and what isn't. And we only render what's visible. So it's like an infinite list. It's what you want with an infinite list, right? You only render what you see and plus some buffer around eventually. And as you scroll, what we do internally is the objects in the array are rebounded to the ones that are visible. So the DOM never changes. Like we don't destroy and recreate the DOM. That would not work at all. Like you couldn't get that kind of frame rate if we were doing that. We're using the exact same DOM structure. We're just re-injecting new data from the different objects you're scrolling through to them, right? So we haven't finished the part where you can lazily, like from a data getting standpoint, get data, stop, use, get data, stop, use. That is on your own to do. But once you reach the UI layer, it's taken care of. That make sense? So one thing that we've also been looking at, and I'm going to close that project, get back to the other one. We're going to do some 3D. We've been looking at 3D as very excited to see that with WebGL. And we've been investing on that for the past 3 years now. And we want to bring 3D to the mainstream and not in a way that only WebGL developer can do it. We want to help package 3D in a way that I don't know WebGL. I can't code WebGL. I never learned. But if you're telling me an object that's well packaged, I probably will be able to do something with it if you tell me which API it has. I don't need to know the inside. That's the whole point. We're trying to build a system where you can reuse someone else's work, but you don't have to know the inside because that's their product. That's not yours. You should just be enjoying it and just using it, right? So we are also very happy to see 2 of our demos which are on the website, the apartment demo and the car configurator, featured by Apple at the last WWDC in their WebGL session when they announced they were supporting it. So let me show you what we're going to do. So here it's a blank app. There's a main reel. That's what if you create something from scratch, that's what you would see. So what we're going to do is launch the preview. I'm going to kill that guy. And the preview is empty because the app is empty. So we have a model here that's a model of a space fighter. So in order to make a model to display, we have a 3D package here at the bottom. So I'm going to take a scene view first. So the scene view bring is div and a canvas to draw, and I'm going to add a scene. So the scene has a path where you can set a model. So if we go to the asset library, I have a model here, which is a Collada model, so a DAE file, which we are converting on the fly to GLTF. So GLTF is going to be a standard this year, a ratified standard by Kronos that we've initiated 2 years ago when I was at Motorola, and 3 years ago, actually now. So what GLTF does, Collada is if you're not familiar, it's a standard file format that takes the output of 3D authoring tool like Maya, 3ds Max, and make it into a consistent XML so you can reload it into another editor. Some editors are better at things than others, so it's how you can exchange stuff. So it's all XML because it was done like 15 years ago. So what we want is that as JSON to be more efficient to process on the client side, but also add features so you can compress to get to your mobile devices faster, and also realign the data so that it's friendly with WebGL, which the Collada standard is not. So that's the GLTF. So it's basically a 3D model as JSON, to simplify. So now I need to add, so the scene view take the scene. So I'm going to grab the scene icon and assign it here. And we're going to give it some size. So let's say the screen is small. So let's say 800 by, let's say 800. OK, so now here, if we should be something here, maybe. Here we go. So here we have this. That's a 3D model I just dumped. Okay. So he comes with his own material, his own lighting. So how about we? I bet that would look better if he was in the dark. If it's a space fighter. So we can go to the main reel and change the CSS, and we're just going to do background color black. Sorry, I don't have the stars, but it's kind of dark. Anyway, so how about we do a stealth space fighter? So if we explore the model a little bit more, the scene has, like the flow, a special editor, which brings us here where it's a dedicated view where you see the bounding box, right? And if you look inside, you can see the nodes, the 3D node, the material, the light, the camera, which there's none here. But there are two materials. So what I can do here is take that material and make it an object. And once I've done that, now I have a material object here. So that material has two properties, image and opacity. So what I would like to do is control the opacity of that material. So I'm going to go back to my library. I'm going to take a slider, and I'm going to add the slider at the bottom. So if everything works as expected, of course it doesn't, where did that slider go? I did not want that to be. OK, let me delete that again. Recreate it. All right, so slider. OK, so now we have kind of clips. So let me add some padding.
Is there a preview code to this one as well?
Sorry?
A preview code to this? If we were
yes, absolutely. You should. Did you try to connect to it?
Yes, it's asking me for the preview code.
Crap. I think I just I just closed the. Where is the preview code? Where did he go? No, I have one already. Yeah, sorry, I ditched it. I'm not sure how to get it back. We can try later. So I'm going to add some padding, padding top. Maybe that will help. Yeah, here you go. OK, so now we have a slider that doesn't do anything. So what we want to do is get the value out of the slider and bind it to the opacity property of the material. So we're going to create a binding on the material. So as we type, we know the metadata. So opacity is going to be bound to the slider dot value. No, not enabled. Dot value. Here we go. So one way, because we don't care otherwise. Or actually, the slider max is 100, which is not good for the opacity in CSS. So what we're going to do is we're going to read that, and we're going to divide by 100. OK, which, let me show you something is, Montage bindings have a full language, logical language in them. So you can write expressions, you can test, you can do map reduce, you can do logical operations in there. I won't recommend that you code the entire app like that. You probably could code a lot, but it's really meant to help keep really UI-related code inside here versus in your JavaScript components code, which is here. So the main JS, like anything you want your owner to handle, like tracking events of the objects inside, applying logic, getting data, sending to someone else, that would be inside the main.js. But for UI logic related, that should be enough. So now, if the binding worked, here we go. We have that guy disappearing, except that guy. That's so much for stealth if your cockpit is still visible. So it turned out that there are two materials in the model. So if we go back to the model to scene, there's a second. You see, there's second. Well, there you go. There's second material here. So we're going to take that one, instantiate here, promote it as an object to use. Then we have that guy, and we can take that binding and duplicate it as well. It's the same object, so it might as well save code. So now if you go here, normally, if we make that guy in the front, then the cockpit should disappear as well. There you go. And again, we could go and look at the WebGL that's being generated or inside that space finder. I'll invite you to do that. Here, you don't need to know that to make that useful. So that was the whole point. And this is obviously not related to that model. I mean, we've done an apartment demo. I invite you to look at. We're working on a medical application with a heart as a sales tool, for example. We've done the car. I mean, there's many applications where 3D is coming to the mainstream that are not 3D high-end first shooter games, and they are very, very useful. I mean, there's a lot of potential in retail, for example, like configuring shoes, configuring shirts. Of course, there's all the 3D printing movement that's also coming. Anyway, so this is our opinion of what a platform with authoring could be and is for the web in a way that brings concepts from existing environments that have proven to be very successful, as much as sticking to the standards and trying to make the most of what people learn and make the most of what they already know without having to ask them to learn too much. Another example of that is the event system. In Montage.js, the event system is completely modeled on the DOM one. So we've implemented dispatch events, add event listener, and remove event listener, which are the three basic and handle events on Montage objects. So if you're Montage objects and you want to dispatch an event, like for example, the slider I think sends an action event like a button does, you can track that event by doing myButton.addEventListener action, this capture and bubble. And we're implementing capture and bubble the same way. The components represent a tree, which is kind of a subset of the DOM tree. And you may want your component, you decide, right, when you create your event, whether that event is going to bubble or not. And if you want that to go, then you want that to go up the chain of your components the exact same way, same API. So we try to really surgically add stuff where it made sense. You won't find any API in Montage, and that's by design, that avoid you to know CSS. No, we will help developer with a more advanced UI tool for that, but it's not through the API. It's through a human interaction. If you don't know CSS, you're not going to be happy with Montage, for sure. So go find a buddy that does know CSS, or go do something else, or more importantly, go learn it, because it's worth it. So let's go back to the slides. back to and mirror that. Here we go.
So I have a question.
Yeah.
So I was loading the WordPress demo.
Yeah.
And it took an exceedingly long time with the spinning W. I mean, is there any way you can tweak like progressive loading, lazy loading?
Yes, yes. So Montage is completely modular, right? So there's a bootstrapping core like you would get in any framework. After that, you're only going to get what you basically put in your reels. So you only load what you actually use, right? So there's two aspects to answer that. First, it shouldn't take that long because mine didn't. I don't know why yours did, but the consequence of being extremely modular is you have a huge amount of file, right? Every component comes with HTML, CSS, JavaScript, right? So that's a lot of moving parts. So when you deploy, we have a process, and it's like right away inside the tool. It's called MOP, which stands for Montage Optimizer. That's doing a static analysis. Again, we know the tree, right? So we can walk the tree, and we can recombine all the HTML and JavaScript is as little as one file for your entire app. Or you can shard it through 6 files if you want to make use of parallel requests. So the next step, which we haven't done yet because it's more complicated, would be a CSS. And as much as it sounds logical that if you were embedded 64-bit encoded images inside a CSS to reduce the number of requests, it would work better. Sometimes it doesn't. Yeah, so it's exactly. It's unfortunate, but so we can go and help more on that to minimize the number of resources call. We could then also embed the CSS itself inside the HTML, but we have to reanalyze all the URLs because they are related to the CSS file. If you put into a style embedded, then things change. So it's not impossible. We haven't done that. So that's the first step, is that you should never deploy a Montage app without mopping it. That would be counterproductive, which is the case of what you're looking at, right? The second aspect is, which is more manual now, but we have a few components, like one of them is a substitution, where you can, like a substitution is like a tab view, logically speaking, but without the UI. It's a component you can tell, okay, when a certain criteria is matched, you're going to put that component in. When another one is matched, you're going to put that component in. So these are components that help you delay the decision of what to use. And you can always programmatically create a component at when only you know, because we have no idea. And then you just insert it when that happens. And at that point, everything is loaded asynchronously anyway. So you have callback method to know, and the draw system is aware that you may have assets that are not there. So basically, the component says, oh, I'm not ready to draw, so nothing happened. If you ask him to draw, he will just wait to get his asset, and then when they're here, then things will kick in. So it's I'm sure there are bugs in there, but it was designed to let you do that. Yeah.
Do you implement some kind of promises system?
Yes, we have in our team the author of Q. So we've been using promises since 2011, and I can attest that we went from 0 to promises everywhere. Just organically seeing the team embrace that pattern, yeah, and it just came naturally. It wasn't. I mean, when I hired Chris Koval, who's the author of Q, he told me about these promises. I was like, wait, what? I was like, oh, brain hurts. And then over time we got used to it, and it turned out to be very, very effective. And now it's coming in the standards. So we've seen many things like that. Like we had bindings very early. They're kind of becoming not really binding, but observing coming in standard. We had the embrace Q very early. They becoming the standards. We had components before anyone else. Now the whole community understand we should be going that direction, though I'm not happy about the current spec, but that doesn't matter to another session, I suppose. So yeah, we use promises. Yeah, it's everywhere. Yeah. So I encourage you to try. We put that out. So let me talk about the business model. Not you may care, but we're a company, so we need to make money. Like any other company, there's nothing wrong with that. I intend to make a lot of money, but we really want to help people go beyond what they do today. So the whole platform, because we know we are on GitHub, we know exactly through the GitHub API whether your product is public or is private. So if it is public, you can use Montage Studio forever for free. There's no cost whatsoever. And of course, we hope that once you guys embrace it, realize what you can do, you're going to want to use it for real work. And if that's the case, then you're going to need a subscription to access private repo after a couple, that we will just let you do that. But after a couple, then you'll need a subscription to go and use that. So don't hesitate, just go use it, no afterthoughts. That I'm the CEO, so I can tell you straight that I'm not going to revert that decision, I think, unless, I don't know, someone change my mind for whatever reason. But it just makes sense, right? We're trying to build a platform based on open source, and that's just the continuation of it, is we want people to use authoring visually without a second guessing and hesitating, because it just works more efficiently for what it does well. It won't change the fact that you may want to go back to your text editor and do a bunch of stuff textually off GitHub and then commit back and then go back in the tool when it makes sense. And hopefully over time, we'll have more and more value to the tool, so you will find yourself spending more and more time there. But we have no intention of doing anything that will lock you in. We're based on the standards, and if there are better tools for certain aspects of the job, or other people that don't want to use Montage Studio that they want to be in, then they should be in, right? And that's where we are. So the future of web development. What I care about that platform is that we deliver superior cross-screen user experience, and to me that's the web killer app. We have to deliver the same kind of user experience that people expect, because if we don't do that, it's going to get marginalized and ostracized, and its market share is going to shrink, and its impact on the ecosystem is going to shrink, and I don't want that. So that's why we're doing it, and I think that's why we all need to think about that. Otherwise, web apps are going to be restrained to admin kind of stuff that we hide inside firewalls, and I think we can do better. The second one is that for that, you need to rely on a strong platform. The standards themselves are not enough. There are stuff that they need to do, like hardware acceleration. There's no way in JavaScript you could ever match the hardware acceleration work that has been done in the browser. It's just impossible. It's not going to happen. But the way the WCC is set, the way people contribute to it, and if you look at the vested interest of the people who are contributing to it, like try to make an equivalent of .NET at the level of standard, trying to get people from Microsoft, Google, and Apple together, and good luck with that. I don't think I may see that in my lifetime. I hope to be wrong, but the thing is, a lot of building blocks are here, so we or someone else can build an opinionated stack on top of what we have to go faster. And whatever coming standard will bring back. Like when the promises are in ECMAScript 6 and ECMAScript 6 is everywhere, well, guess what? We'll remove Q from Montage, and then we'll swallow that cost for you. Same for the web components. You can, if web components were everywhere, which they're not, there's no reason why you couldn't use the web components inside the Montage components. That will work. We'll make it work. Another very important thing is bringing web designers, developers together. And that's taking a higher view of, OK, tools for web designers are great. Tools for web developers are great. But if they are incompatible in terms of output with each other, I mean, there's no point, right? If your web designer or interactive designer are using Balsamiq, they spend 6 months doing a mock-up. In the end, you have a Balsamiq movie, right? Then you have to go from scratch and implement that in whatever stack you choose. Actually, but it would be iOS, Android, or whatever. It's just stupid, right? On the web, we can do better. Our goal with Montage Studio at some point is to have a balsamic implementation inside Montage Studio so that the interactive designer interacts directly, mock up their UI with real components. They may take shortcut and do hideous thing that the developer will have his hair off, not me, but then that's fine. He can undo that, make it better. He doesn't have to start from scratch. And by the way, the right way these guys work together is iteratively. At each iteration, you pay the price of their tools not working with the output you want, which is going to be the final thing the product is going to be in. It's just stupid. We need to fix that. And that means growing from just coding everything by hand to interactive authoring. Like on the native side, people were hand coding in terminals until the Mac came up, and after that as well. But they've stopped doing that all the time. Why? Because it turned out it's more efficient. That's all. It's not a matter of opinion. The facts, the decades of facts are there to prove it. The same is going to happen to us. It's just like the writing on the wall. We just have to look back and look around, and that's what's there. The same is going to hit us. The web stack has grown from learning from what was done before, as it should, because there is some good. It doesn't have to be taken straight away again, but he has to be looked at. And real-time preview. So that's what I showed you. And that starts by not using builds. Like when I see people using a tool chain that asks them to do a build before they can test what they're doing, I'm like, what are you doing? Just go to native and use a compiler if that's what you need. That's wrong, right? Our CommonJS implementation doesn't require a build. Because why? Like you have something that you just reload, which is supposed to work. That's how the platform is built. Why would you hurt yourself by injecting a roadblock in your own time, right? It doesn't make any sense if you can avoid it. And so far, especially I can tell you with the cloud setup that we've set, even running mob, for example, which is a tool, right? You have to run the command line. Now you don't have to remember the configuration. You just click a button like mop, prepare for publish. Boom, we do that for you on the back end. It just runs. Anytime you put a build in your face, you're just slowing yourself down. So that's the same thing as real-time preview. Why have to wait, reload your page to see what you're done iteratively on several devices when you could avoid it, right? It's all part of the same train of thought. And well, I think we already started showing some of the future we think we can do. So in the end, I would like to finish by saying that HTML5 is not a buzzword, that it's an amazing technology, even though it's not finished by any mean. It probably won't ever be. There will be HTML6 and 7 and whatever, and then the stack will continue to grow at this pace. And no matter how fast Google wished the world would go, it's going to go at the pace it's supposed to go, which is by agreement. That's how we got so far. Yes, people are frustrated because it's not super quick, but that's how we work. So I encourage you to just go and try and work with the future. Thank you.